Okay. Wow, we're here. Hello, everybody. Welcome. Very happy to be here today with all of you and on this stage with this wonderful panel of speakers. My name is Aaron Sternberg. That's me. I'm on the Cloud Partnership team, which is part of a larger Unreal Engine partnership division. And I will be your host today as we dive into this session, Unreal Engine in the Cloud. So, as many of you might already know, Unreal Engine, over the years, has built quite a reputation of being one of the most, if not best, real-time engines available in the market, capable of delivering state-of-the-art graphics, powering some of the most recognizable video games and experiences in the world. So today, we're going to show you some use cases that are newer, which you might not be too familiar with, but we're very much excited about. You see, we believe that cloud will play a transformative role in the future of content creation, the accessibility of experiences and creation tools, as well as enabling geographically dispersed teams to work more closely together effectively. And because of this, Epic Games is positioning Unreal Engine as a first-class citizen in a cloud-first ecosystem by adding features like pixel streaming and supporting foundational technologies such as containers and Linux. Lots of good stuff. In fact, the opportunities enabled by leveraging the power and flexibility of Unreal Engine running in the cloud, well, they're endless, still relatively untapped. So today, with this talk, we want to give you just a little taste of what's possible, hopefully to inspire all of you to explore the space yourselves by using technology and solutions that Epic Games and its partners offer as a starting point. So that's the session today. We're going to break it into 3 sections. In the first section, we're going to talk about how Unreal Engine can be used made much more accessible from the cloud to create content. Then we'll discuss how high-quality Unreal Engine content can be consumed from any device through any browser with the technology known as pixel streaming. And then in our third and final section, we're going to get just a little bit technical as we will be presenting technology that really is known today as the de facto standard for cloud solutions, containers. That's right, containers now support Unreal Engine. We're excited about that, and we encourage all of you to check that solution out where possible. So I've talked the talk, so now it's time to walk the walk. That's why we've invited this awesome group of partners who have successfully delivered UE-based cloud solutions, so we can hear from them directly on what those solutions look like. And of course, we have other awesome partners and solutions. We just do not have enough time to go through all of them. So without further ado, I'd like to introduce Laura from Arch Platform Technologies as we kick off this first section in content creation. Thank you.
Thank you, everybody. So glad to see all of you so early in the morning after a truly epic party last night. So thanks for coming out. I'm going to talk a little bit about building Unreal Creative Studios in the cloud. I'm the CEO of Arch Platform Technologies, and we have an offering that makes this actually quite easy to do. So who is Arch? We're a software company. We're not a systems integrator. We're not a bespoke consultancy. We're a software company, and we offer a platform. It's a SaaS offering to provide creative infrastructure in the cloud. And what that means for all of you is that you can build end-to-end, fully resourced cloud studios for digital content creation in under an hour. You can run your Unreal workloads there. You can move your creative teams to the cloud. Not only can you build these studios, you can monitor them and you can manage them. And this is where the real power of the platform comes in. We're an official Unreal Engine cloud distribution partner. That means Unreal runs out of the box on these workstations, no additional downloading, installing, registering, et cetera, et cetera. And we got our start in 2016. The company was launched to build the world's first VFX company in the cloud, before anybody thought this was really possible. Since that time, we have built 3 generations of the platform. Latest version was released in 2020 for wide availability. We've moved beyond visual effects, and we now support all sorts of workloads in the cloud, from editorial to color to Unreal workloads. And our customers include studios, post-production companies, game dev companies, esports companies, and engineering companies. So we talked to a lot of people who want to move Unreal to the cloud, but there's a fair set of challenges in doing that. I mean, there's a lot of technical folks out here, but maybe aren't really familiar with cloud services or providers. Or if you are, you don't want to actually take on this challenge and build everything from scratch in the cloud. I mean, it's one thing to get an Unreal virtual workstation, virtual desktop working in the cloud, but it's something very different when you're doing substantial work. And you really need to have groups of teams working together, lots of workflows coming together. You need other kinds of resources that you might have in an on-premises environment. How do you get all that up in the cloud? How do you make sure it's secure, it's auditable, it's audited? If you work for an enterprise company, you're going to have to deal with InfoSec and ContentSec and identity providing software and everything else. And maybe in the totality, when you look at it, you think, you know what, maybe I don't exactly want to do this. There must be a solution. Well, there's a solution. It's called the Arch Platform. So it's all fronted by a SaaS dashboard that drives an orchestration engine, which can build secure facilities in the cloud in AWS with workstations, storage, licensing server, connection manager, broker, maybe a code build pipeline or a render farm if you're doing traditional kind of more VFX or asset creation. And the key thing is that we get data back from this facility in the cloud. We get metrics back. We provide data analytics. So you really understand your resource utilization, whether those resources be computational resources, human resources, can really understand how to make that environment more efficient. So for a lot of you folks out here, Unreal is where kind of most of the magic happens. But if you're doing other kinds of work where you have to interact with other software, you need other services in your facility, we have tight integrations, right? So we're partnered with all of these companies that you see up here. So for example, when you build that facility, you can check, oh, I want a Perforce server, or I want Incredibuild, or if you're a game dev company, maybe you want Plastic. You just select them all, hit go, and in an hour, you'll have your facility with all of these things already in there, ready to go. Maybe you need high-performance storage like Weka. Again, we can provide that out of the box. We're partners with all the digital content creation companies, so we really understand how to put this software on the right machine so they perform their best. And of course, we're privy to their product pipeline, so we're always ready to deploy the new version of the software on the day it's released in the best possible configuration. You can access the virtual desktops through HP Anywhere, formerly Teradici, and Parsec. We have a very, very nice integration with Parsec. It's one click, drops you right into the desktop. So right now we support AWS. We're moving towards being cloud agnostic. There's a lot of benefits in working in AWS for us right now. Wide reach of data centers. We have facilities deployed, these content creation facilities deployed across the US, across Europe, in South Africa, in India, and in Asia. Rich collection of GPU machines. And so what we're able to do is find the right machine for the workload that you need to run. So for example, right now, there's this kind of sweet spot of the G5 instances, the G5 8XL with an A10 GPU, an AMD CPU, and some really, really, really fast NVMe. And we're getting exceptional performance. Our customers are getting exceptional performance on Unreal Engine and tools like Nanite. So I'm going to dig in a little bit. I'm not going to do a demo of the platform. I'm going to show some key elements of it. We have a little movie on our website if you want to see more. Also, I have my laptop with me. If anybody wants to do a demo afterwards, I'm happy to do that. SaaS dashboard drives an orchestration engine, a machine image pipeline, and analytics and monitoring. You're also able to manage your users and teams, so you can assign groups of workstations to teams of users, so nobody is ever over-provisioned or under-provisioned. License management, all sorts of cloud license tools. So if you're using any tools from the Foundry, for example, you can see what you have, when they expire, who's using them at any time. And this dashboard is key. I mean, this is where you see all your analytics. It's a beautiful thing. It's not like working with the AWS console or the Azure console or any of those. So you get to see who's logged in when, what workstations they've used, and you can dig in the top to see more data about workstations, render, storage, etc. So that dashboard drives an orchestration engine. a series of cloud formation scripts. Remember, this is product, so everything's repeatable, everything is auditable. So we run our orchestration engine in an account of ours, and we can deploy into your AWS accounts with guardrails and least privilege. So we can build multiple facilities. People have multiple facilities because of geographic region or different projects that they need to silo off together. And we're working with a broadcaster, for example, as different cost centers, and they need to deploy in different AWS accounts. If you don't want to do that, we can deploy into a sub-account of ours, and you never have to know anything about AWS. You just work with us. Machine image pipeline. This is how we build the machine images, and this is how you can maintain them. And this is actually it's a cascading pipeline, which means that it's really easy to update software and to put out a new machine image. And it's really easy to update all the machines in the facility that are using that particular image. So for example, you can start with an operating system layer, then layer on a creative tools layer, and then maybe a game engineering level on top of that. And you can go in and you can update your software at any one of those levels. We have over 450 applications already scripted in a GitHub. Scripts get pulled out of our GitHub. If you have your own GitHub and you want to install your own software, like maybe you've got a build pipeline or something, we have a GitHub, we're a GitHub app integration, so we can tie in directly to your GitHub, and you can use your own scripts to manage the machine images. Analytics and monitoring. All the resources in the facility have an Arch agent on it, whether that be render nodes, compute, build pipelines, all the workstations, storage, et cetera. So we can get out machine metrics, user metrics, metrics on HP Anywhere and Parsec, right? So we can really understand what's happening with your connectivity, and nice DCV is coming. So up here you can see a little bit again, our goal is to make everything accessible, easy to read, and you can basically see, on top, which workstations have been used by which user, for how long. And here we can see the PC over IP metrics, because often, an artist or somebody would say, my machine is slow. AWS is having a problem. It's never AWS. It's usually their internet connection at home. Like they're on Wi-Fi, or their kid is playing Fortnite, or something is happening, right? And so this helps us really debug all of that stuff, or our customers debug all of this stuff. So what's the takeaway? I went through this really, really quickly, and I'm happy to elaborate more. And certainly there's more info on our website. But we enable a seamless move to the cloud for Unreal creative teams. There's no systems integrators needed, no cloud engineers needed. We can build a fully resourced creative facility. And we've been doing this for a long time, so we bring a lot of domain expertise to the table to really help sort of suggest what kind of configurations and machines might work for whatever your workflows are. Unreal 5 is ready to work out of the box. We can work all over the world. And we have customers using this, as I said, for traditional post-production, for virtual production, whether that be an on-site virtual art department, or game creation, or just traditional virtual production. We have customers using it for architecture and engineering as well, and game development. So we have a number of game dev companies, and we signed our first esports company actually quite recently as well. So should you need any more info, that'll take you to our website. And as I mentioned, there is a movie, like a small movie in the Arch platform in action, and you can always call us, and we can hop on a call and do a demo, or I can do one here at the conference. So thanks very much.
Okay, thank you, Laura, very much. Appreciate that. A good perspective on M&E with a little taste of games. For a little bit more on the cloud game development, introducing Ben from Microsoft.
Hello, everyone. My name is Ben Humphrey, and I'm an engineering manager at Microsoft. And my team builds solutions in Azure to help game creators better leverage the benefits of developing their games in the cloud. So like many of us have seen over the last couple of years, things have changed, and the new shift to remote workers and geo-distributed workers, it's been quite complex and changed some things up. And at Microsoft, we've been looking at how do we build solutions to be able to help support those who are looking to adopt that new paradigm shift and develop in the cloud, as well as be productive, and be more productive more quickly. So just out of curiosity here in the room, how many people are still working remotely in some capacity? I'd raise the hands. It's quite a lot. It's pretty amazing. And most of us, if I'm actually looking around. And so to be very transparent, I'm a huge fan of the remote development new paradigm shift. It's really where things are going. And so it's been awesome to be able to work with some partners such as Epic Games to be able to build things that can help enable people to get started on that journey quicker. And so what we've done is partnered with companies such as Epic Games and leveraging the power of Unreal Engine and of course using our tools at Microsoft Visual Studio and such in our gaming tools, and also things like Perforce and Incredibuild tooling and HP Anywhere and Parsec and more to be able to create the game development virtual machine. Essentially what that is it allows you to be able to have a GPU that you can spin up in minutes that has many of the core tools that you're already using today on your local desktop. And so we mentioned some of those partners, and you can see them here. And essentially, within minutes, you can get spun up and have a GPU workstation, or even have a beefy build server ready to go. And especially as people are trying to get into this for the first time and dip their toes into it, it's a great way to get started without having to worry about the different configurations and think about all the installs and all the hours it would take for you to just kind of get started in the basics, just to even feel what it feels like to do remote development in the cloud. And we realize that it's not going to be having every tool in every configuration, and certainly more is coming, but the thought is if we can build something that can bring you maybe that 85%, and then you bring your secret sauce and your own tooling configuration on top of it, it's just so much easier to be productive and quickly get it set up. So when we look at who is actually could be using the game development virtual machine, certainly developers. You think about spinning up big GPUs, beefy GPUs, servers up in the cloud. Also, when you look at like doing bug fixes and working in maybe previous projects or even releases of games, and instead of having to configure your own system to have those unique environment settings that had maybe a while back, now you can just spin that up in the cloud, use it, and then shut it down, and you're only paying for that compute when you need it, or just get rid of it altogether. Also, one of the common threads we're seeing is around vendor support, right? So when you have especially geo-distributed vendor support, you don't want to have to wait for them to maybe get Threadrippers or GPU devices because of the logistics issues. And so that's a really quick way to get them spun up and start being productive quickly. Also for artists, certainly we have things like Blender and the great tooling, of course, of Unreal Engine to be able to use for our tools. And we have more coming, and excited to share those when those come out. And then, of course, for the build engineers. So, think about, we talked about GPU workstations for the developers, but also for the build engineers and having all that common tooling on there already with Unreal Engine and Visual Studio and other tools to just use those and build out beefy workstations for your build servers, or leverage things like Incredibuild to then scale out even farther, which we'll talk about in a little bit. So I wanted to talk about getting started really quickly with saying that, but what does that look like? So in here, I'm just going to walk us through the Azure portal of what does it look like to actually spin up and do the game development virtual machine. So in this case, say you've started out in Azure, you're new, and you've got some GPU quota, and you want to start spinning up a workstation. Well, you go to the top and search game dev, and it'll come up as Azure Game Development Virtual Machine, and you click that, and you'll run into this. And then you're going to hit the Create button. And that's going to take you into the wizard of all the different configuration options. Of course, everything can be automated, but we'll just walk through this UI experience so you can see all the different customizations. So when you're going to spin up, as you're spinning this up, you're going to choose your subscription, also your region. The region is going to be very important because the closer you are to that region, and we have over 60 announced now in Azure, that's going to be the best experience. Then, of course, you're going to go look at your SKU. What hardware do you want? Do you want a big beefy GPU? Do you want a big build server? And you choose that. And of course, you got your login and password type stuff, but we also support Azure Active Directory, which we'll show you in a second how to set that up. And in terms of the OSs, we have Windows 10 and then also Windows Server. Windows 10 is great, it's in the cloud, and it supports things like DirectX 12 with the agility functionality, which is important if you want to be doing things like UE5 with Nanite. And we're going to have more coming. So also you go pick your engine. Well, if you say, well, I don't want an engine, I just want to start and maybe build Unreal Engine or something from scratch, you can do that. Or you choose some prepackaged Unreal Engine, say 5 or 4, and more versions will come that you can then look back to and you can use and deploy later. And once you choose that version, then you're going to see the different options for the different IDEs that you get. Visual Studio Code for those who might use that. Also Git or Perforce. And if you use Perforce, you can actually select a way to just download a depot. So the VM would spin up, it would download Perforce, and when you come back and log in later, it'd be ready for you to have your project already set up. We also have the option to bring your own license for IncrediBuild licenses. And so IncrediBuild allows you to scale out outside of that VM and maybe spin up many spot VMs to do that compute that you're doing for building. Or you can use the 30-day trial that comes with that. As we look at how do you want to get into that VM, there's certainly RDP, which is very common, right? And we turn on GPU acceleration for that. But there's also great tooling like HP Anywhere or Teradici and Parsec to be able to get even more capabilities and more interactive, especially when you're doing like AAA type of content. We also support, of course, virtual networks and make sure security is there. That's very important. And you can also sync in with your on-prem networking too. And one thing that we found is when people go and try to spin up, they try this for the first time, and they spin up a virtual machine, and they're like, oh, the performance just isn't there. Well, we find a lot of people, they just use the OS disk. And so what we guide you on is, say, well, you're not just going to want just the OS disk. The performance and things is not going to be there. So you're going to want to stripe disks together or use things like UltraDisk, which give you even higher IOPS. Since we have a little dial in there that shows you what performance you're getting. We also have SMB shares that you integrate right there. We can even give you the option to choose, Azure Active Directory if you want to log in through that approach, and even Azure Virtual Desktop to give you that little more enterprise side and IT control to be able to spin up pools and different things that you can manage. So say let's go in and actually create this thing, and within minutes this will be up, and let's just kind of fast forward and look at what does it look like to use something like HP Anywhere to log into the cloud. So I'm out of Dallas, and so this is me logging into South Central US region and using HP Anywhere. You come into the VM, you have all the tools there, and there's more, of course, not seen in the links. But let's actually spin up Unreal Engine in here and see what that looks like in the experience. So I've downloaded the great medieval demo, which many people love, including myself, and just show some great content and that interactivity. So this is actually a recording of me going into the cloud and using this. So I'll hit play, and we'll see that as I'm kind of walking around, that you can get the experience of it. This doesn't feel like I'm actually remoted into a remote computer that's somewhere away. It feels like I'm on my desktop. There's that interactivity. I can get high frame rates and even scale up, and in terms of going greater than 1080p and such, especially with tools like HP Anywhere and Parsec. So as you can see, that was all real time. We recorded me going into the cloud. And let's actually talk about how does the game development virtual machine fit into the cloud development pipeline. So if you're moving to the cloud, as you know, you're going to get the best benefits if you're actually putting your assets in the cloud, right? If you just kind of spin up the VM and you're just trying to hit your VPN such through the on-prem, it's not going to be as great as experience as actually moving stuff like, say, like Perforce and proxies and such into the cloud. So in this case, we could certainly just focus on one region and show a diagram, but let's actually make it a little more interesting and more realistic and do with geo-distributed teams nowadays. This is an example of multiple different teams potentially working across different regions. So you got Azure Region A, and you're using the game development virtual machine and using something like HP Anywhere maybe to log in, and using Unreal Engine on that to do your development. And then, of course, you have a Perforce proxy and such in that region, and then that's syncing to your primary region over, say, an Azure Region B, or that could actually be your on-prem where your primary for Perforce is. And that's where you spin up your build pipelines. And we saw that the game development virtual machine is great for workstations, but also you can use it for that build server. And that build server will have IncrediBuild and all the coordinators and orchestration and beefiness that you need, and then even to scale out into more of spot instance VMs with the IncrediBuild. And then once you take that build and maybe push it to something like blob storage, and then you can use that either to pull down to on-prem, maybe if you're doing an Xbox console development, and you can pull that down to your dev box, or have that sync across to a different region, and then maybe even testers in a different region could then be taking that build and then using it. One of the awesome things with the game development virtual machine that we're pretty proud of is we install a signaling server, which is the pixel streaming backend, to be able to use pixel streaming right from that VM. So when you spin it up and you click that you want that, we enable that so that you can now collaborate in that VM without having to give people potentially 60 to 100 gigabyte builds. It's just right there you can see. And I was so excited to hear earlier that with Unreal Engine 5.1, now pixel streaming supports in-editor pixel streaming. So I'm super excited to get that in our team and working to add that quickly and configurable in the game development virtual machine. So thank you for listening. If you haven't tried, and you haven't tried even doing anything in the cloud, please check out the game development virtual machine. You can do that through aka.ms/gamedevvm to get started. And also, if you have any questions or need guidance, you can reach us at thegamedevvm@microsoft.com. Super excited to be here, and thank you so much. And I'll turn it over to Aaron.
Thank you, Ben. Did you say pixel streaming? Huh, what are the odds? All right, our next guest is Quentin from Eagle 3D, which we will kick off our next section in content consumption. Quentin.
Yes, thank you, Aaron. And yes, we did mention pixel streaming. So, hello, everyone. My name is Quentin Anderson. I am the co-founder and CEO of Eagle 3D Streaming. We help companies publish web applications to the cloud. So we do the front-end work, the UE work, the back-end work, and we also have a self-serve platform so you can upload your Unreal app and publish it to the web. And so I'm going to spend a little time talking about the makeup of a cloud-native application by going through a case study that we recently did on a project for JLL. So there's multiple different ways that we can deploy our Unreal Engine applications. Some of the usual suspects are VR, desktop, mobile, console, but there is another deployment mechanism that's becoming a little bit more popular these days, and that's the browser. And the reason why the browser is so interesting is because it removes the hardware and software dependencies of your deployment. So gone are the days where you're hoping your client has a 2080 or they have the right operating system or the right device, because now we're running everything natively in the cloud and we're just streaming the output to the user. So as long as they have internet, then they're able to interact with your application. And the best way to explore this is to go through a case study of a project that we recently did for JLL. They're a Fortune 500 real estate services company, and they wanted a digital replica of the entire globe so that they could gain real-world insights on certain cities and buildings of interest. This is one of my favorite slides because it provides a breakdown of the application, and this is a really good backbone of most cloud applications. There's always going to be probably these 4 layers. The first layer, of course, is the front end, and this is the access point of your application where your users will sign in through a browser to your app. The next piece that we always have to consider is the streaming. So since we're not accessing the application locally anymore, we have to figure out which cloud are we going to use, which regions are we going to deploy in, how many users. So there's always going to be a streaming component. The next piece, of course, is the Unreal Engine application itself, which is the backbone for any cloud-native UE app. And then there's typically some back-end data that's streamed into the application to provide some real-time insights. A good example of some back-end data that we did for this application was we used Cesium. So we used the Cesium UE4 plugin, and we streamed in both the tiles and 3D building data of various cities. And this was really great for us because Cesium has a lot of data all over the globe so that we could quickly create these cities, which is what the client was most interested in. So this is an example of Melbourne, which we just grabbed the tile data as well as the 3D information. And then we also have Abu Dhabi as well. And so that was the first step, is first ingesting Cesium tile data, 3D building data, and then we took data. So we worked with JLL, and they have, of course, large reservoirs of data, and we visualized it through a HTML data visualization tool. And we didn't do it inside of Unreal. And if you're wondering, well, why would you do that? If we're deploying to the web, we can actually leverage a lot of the existing charting technologies. So there's already a lot of powerful visualization tools on the web, so why not, since we're deploying to the browser, take advantage of some of those? So instead of reinventing the wheel inside of UE, we just visualized all the data in HTML and layered it on top of the Unreal Engine application. And that's one of the things that we like to stress, is harnessing the power of the browser since we're doing a cloud-native deployment. And then, of course, we had the Unreal Engine application where we did all of the 3D work in, and then we had all the game mechanics of panning, rotating, zooming, selecting, drilling into buildings, drilling out of buildings. All of the game development, of course, happened on the UE layer. And then after we had the application finished, the next piece was the deployment. So in this project, our client specified for us to use Azure because they were already on Azure. And so we started with there's a marketplace SKU that you can use as a starting point. So we used that to deploy the application, and then we made some modifications based on what the client needed for their specific project. And then when it's all said and done, you're ready to deploy your application to the web. So I've prepared a little demo that I'll kind of walk through the experience. The first thing that we'll do is go to the browser and enter in a URL address, similar to going to a YouTube address. And then after we do that, we're greeted with the application. We had a globe selecting mechanism, and then after we selected the globe, then we could dial into different cities. So here are the examples of the cesium data that we had inside the application. And then after that, we started to layer on data insights. In this example, we took Riyadh and we separated it into the sectors of Riyadh. And then whenever I selected one of those sectors, then I got real-time insights associated with that sector. So I could determine the total occupancy rate or leasing pricing or total GLA value of that area in real time. We could also do that at the building level, which is another great insight where we could select a building or we could select a floor and determine the occupancy rates. So how active is that floor? How active is that building? What is the activity relative to the other buildings in that area? So we use the 3D data from Cesium as well as ingesting additional BIM models to fill out the area, and then we attach the messaging system so that we could send, whenever we selected a floor or a building, we could send that information to the front end and display data associated with that building. So when it comes to building an application in the cloud, there's a lot of key benefits that it provides. One of the first benefits is that, and the main one is, it removes the hardware and software dependencies. So a lot of the challenges that we see commonly with deployments is making sure that the end client has the necessary hardware in order to run the application. We can get around that by deploying it in the cloud and then just streaming the output to the user. And that's one of the key benefits that we see with using cloud-native applications. It also unlocks the full potential of Unreal Engine. So now that we're in the cloud, we have a little bit more leeway with the boundaries that we can push. So we can make the experience as high fidelity as possible because we're running it in the cloud and all we're doing is streaming the output to the user through the browser. And also, since we're in the web, we can take advantage of existing web technologies. A really good example is we actually use charting visualization tools that already existed, and that reduced the development cycle of this application, and it also made it possible for those applications to be scalable and responsive based on the browser. Another thing that we'll have to consider is the streaming deployment itself, and in this case, we use Azure, but there's always going to be decisions when you're thinking about your cloud deployment. Which cloud are we going to use? Where are our users located? And another important one is how many users are going to be connecting, because we'll have to be thinking about how many concurrent users we're going to have for the experience so that we can start planning how many virtual machines we're going to need in order to satisfy the deployment. And then, of course, don't forget to always stream data into the application, and you can do this through a desktop application and a VR application, but it's sort of nice when everything is in the cloud and the overall strategy is a cloud-native one, and you're trying to stream as much information as you can into the app rather than having all that information just hard-coded into the app itself. And always remember that we can leverage the front end. An example, we connected portfolio information to where if we ever select multiple buildings, then I can save that selection and then later call it. And after it's called, then I can get information associated with that specific selection. So it was a lot easier to send messages between Unreal Engine and the front end rather than trying to do everything in the engine itself. And the last piece, which we kind of saw at the very end of the demo, is we can make it responsive, which is another key benefit. So we can deploy it to a single cloud, and then whenever we connect via a browser in portrait mode or on the laptop, we set up this application to where the resolution actually updates based on whatever device you're connecting to. So a person having a mobile experience on portrait, the resolution will actually update to that device, versus if a person is interacting with a laptop, then the aspect ratio will be more of a landscape orientation. And all this is important because cloud native apps help reduce the friction of the deployment, And the most important thing is that it helps provide the best possible user experience to our customers. Thank you.
Thank you very much. That was awesome. Okay, cool. Next is the last section, creation tools, and Luke with TensorWorks. Thank you.
Thanks, Aaron. Alrighty, hey everyone, how's it going? Everyone enjoyed the party last night? All right, so container tools and use cases. So we're going to be talking about what I think is a rather foundational tool for deploying to the cloud, and really another tool in your developer toolkit, if you will, when you're thinking about your cloud deployments with Unreal Engine. So a little bit about me. I'm a director at TensorWorks. That's my company. Background, I have a PhD in computer science, background software and game dev. Been an Unreal Engine user since the UE4 beta when it was Rocket. And I'm the lead developer of Pixel Streaming plugin. However, I won't actually be talking about Pixel Streaming today. We're talking about containers. All right, so what are containers? So containers are a modern, lightweight alternative to traditional cloud deployment technologies like VMs. So sort of a little bit of difference between VMs and containers. Basically, it all comes down to VMs. It's in the name, virtual machines. So we're virtualizing the hardware. We're accessing the virtual kernel, so on and so forth. Whereas containers, we have direct access to the hardware and the kernel. So they're a more lightweight mechanism. And when we're deploying at scale, particularly when we have a high density of containers on one machine, we can see large improvements when we're using containers over VMs. So some benefits here, as I mentioned, they're a foundational technology which really all cloud native deployments can benefit from. They also have largely become a de facto standard over the last few years when we're talking about cloud deployments. They're very good, like VMs, because they're portable and reproducible, but they're a bit more efficient and cost effective. And there's also a very strong tooling ecosystem with things like Docker and Kubernetes when we're trying to orchestrate at scale. So historically, Epic and Unreal Engine cloud deployments have historically relied on using VMs. However, Epic is actively making investment in improving the container deployment story today, and I'll talk a little bit more about that by going over sort of the history of how we got to where we are today. So in 2018, my colleague, Adam Wren, he created the UE4 Docker open source project, which was providing development images for Windows and Linux and really inventing Unreal Engine containers as we know them today. And that sort of started as just a grassroots project that he was super interested in digging into. And then lots of people started using it and Epic started taking notice. And then from there, he created the UE4 Runtime open source project, which is a little different because that's for running your packaged Unreal Engine applications as opposed to running the entire editor in a container. And then from there, we made UnrealEngineContainers.com because so many people were asking about these containers and how you use them with UE. And to this day, I still recommend that as a great source of information for people to check out. And then 2020 to now, TensorWorks has been collaborating with Epic Games to introduce official container support in UE since 4.2.7. And we've been improving container tooling through 5.0 and also 5.1. So since 4.2.7, we've introduced a few new tools to power cloud use cases and cloud deployments. In particular, we now have a number of pre-built container images, so you don't have to build them yourselves. You can just pull them from our GitHub org. We also provide some example code in the Unreal Engine mono repo, and there's a number of learning resources that we've started sharing with the community now to get started on the container story. So with the pre-built images, they come in two different flavors. So when you're playing with these, we have the development images, which are on Linux, which is the full editor in a container. This is around 30 gigabytes or so, and this is useful and suitable for building your projects automatically in the cloud and automation, packaging, cooking, that sort of thing. We need the full editor. And then there's also runtime images, which is where you've got your packaged Unreal Engine application and you want to run that in a container. So this is a much more lightweight image, and this comes in Linux and Windows flavors. So the example code I mentioned, this lives in the Unreal Engine mono repo under Engine Extras Containers Examples. And we ship a number of examples since 4.2.7. In particular, I recommend checking out the Pixel Streaming Docker Compose demo, which will stand up the full Pixel Streaming setup for you by just running basically a few Docker Compose commands. The learning resources I mentioned, these two in particular, on top of the Unreal Engine containers website, I recommend you check out the white paper we published, which is basically a little bit of sort of theory about containers and then also going over a number of use cases where they're being used today already. And then the Cloud Solutions Unboxed, the Unreal Unboxed video series that we worked on, is also a great way to get started with containers and check out what you can do with them in Unreal Engine. So they have a broad number of use cases. I touched on a couple there. So continuous integration and continuous deployment, so building your Unreal Engine projects in the cloud. This is an obvious one for us, and we see a lot of people using the images we provide to do that. Pixel streaming, of course, we've heard a little bit about that today, and containers is a great way to combine with pixel streaming because we can get a higher deployment density by using that. AI and machine learning, rendering of linear media, and Unreal Engine microservices. So even though the Unreal Engine is actually quite massive and it can do many things, if we're putting it in a container, we can really leverage the full suite of things that it can do. And we can actually, if we're calling that, if we think of it as a microservice or a web endpoint, we can really call that as a, I guess, a service there. So Unreal Engine microservices is a growing use case for sure. So continuous integration and deployment, here's an example here of something we've built at TensorWorks, which is Admiral Build System, we call it. And basically this is our continuous integration and deployment, packaging and automating building of Unreal Engine projects. And this is fully using the container images that Epic Games provides. Pixel streaming, of course, as we mentioned, can also be running in containers for greater deployment density. AI and machine learning, this example is one of my favorites of people using Unreal Engine to train autonomous vehicles. So they have a fully virtual city here and then the car drives around it and is trained to, you know, not hit things basically. So in this case, they're running the whole thing in containers and then basically doing nightly builds training the AI. Rendering of linear media. So in this case, we're basically treating Unreal Engine like a render farm or a render server. And with the visual fidelity that UE is pushing out these days, this is increasingly an interesting use case for containers. So what I'll do here to sort of finish up the piece about containers is show an example of how you might use containers to build an Unreal Engine microservice. So this architecture here is quite generalized, but this will apply to a number of use cases if you are considering building an Unreal Engine microservice or a container deployment story. So we'll have the ingest service, object storage, a job queue, and then these Unreal Engine worker containers here visualized, which could be 6 in this case, but it could be up to any number really. So we start with an ingest service receiving a job from a user. So in this case, let's say we're talking about rendering linear media. We might get a request saying, okay, we want to render something in Unreal Engine. The ingest service is then going to place some input data into storage saying, okay, we got a request from the user, this is what they want to render. They want to render a car or something like that. And then the ingest service is going to add a job to the job queue. And then from here, the job is going to be assigned to our pool of Unreal Engine workers. And these workers are really actually just a set of containers containing the Unreal Engine. And then the Unreal Engine worker retrieves the input data from the object storage saying, yes, we want to render this thing. The worker will then process that input data, and in the case here, we're going to do some rendering. And then once that rendering happens, we're going to output that back out into the object storage. And then from here, the user consumes the output data. So basically, we're using object storage, IDEA, ingest service, and job queue as a scalable mechanism to create a microservice. In this case, rendering linear media, but this could be really any Unreal Engine feature that we want to use in the cloud. So that concludes the container piece. Thank you very much.
Thank you. Powerful stuff. Thank you, Luke. Thank you, Laura, Ben, Quentin. Appreciate it. So there you have it. A great session on content creation, content consumption, and creation tools. Really great stuff. Tastes good, doesn't it? And what's possible? Also, guess what? Epic Games has also published some building blocks. So you can go to AWS, Google Cloud, or Azure Marketplace, go into the search box and type Unreal Engine. Check that out. And then finally, please keep an eye out for other partner solutions and other cloud marketplaces. Thank you very much.